All right, everyone feeling pretty good about the inscribed angle and then the intercepted arc? Yeah? Okay, that's the setup. Here's what we're doing now. Box number 2 is putting 4 theorems onto our toolkit. Okay? And they're going to be 10.8 through 10.11. Okay? 10.8 through 10.11. So set up your toolkit right now for 10.8, 10.9, 10.10, and 10.11. And then I'll show you each one. All right, 10.8. Here we go. Okay, so check this out. There's a program called GeoGebra. It's free. You can download it and you can make all these things in your house and all kinds of fun things going on. Okay? Yeah, it's called GeoGebra. Okay, I'll move the theorem over here. No, I'm not. It's free. You don't get paid for anything. It's only free. Yeah. Okay, here's what the theorem says. It says the measure of the inscribed angle, which is the little one over here. Here's the inscribed angle, is half the measure of the intercepted arc, which is this over here. So if I move these around, they should stay. One's double the other one. So see, as I move it around, no matter where you stop, right? 64 degrees is the inscribed angle. Then 128 degrees has to be the intercepted arc. No matter how far around I go, right? It's always going to help out. So 100 and 200. So there you go. So the theorem says this. It's up here in the little box for you. It says the measure of the inscribed angle is half that of the intercepted arc, and we can see that going down right here. This angle, 57 degrees, is half of 114. From C to B is the intercepted arc, and angle D, the algebra spreadsheet out of the way. Okay, here we go. Theorem 10.9. Here's what it says. Okay, here's what it says. Notice I have one arc here. The arc that I have is from B to C. That's the arc that I have. And that arc is being intercepted into 2 inscribed angles, angle D and angle E. What do you notice about D and E? They are congruent, right? So here's what it says. If 2 inscribed angles of a circle, so this one, angle D and angle E, intercept the same arc, and the arc that they're referring to is from B to C here, then the angles have to be congruent. And this is true no matter where I move B or C around the entire circle, right? They will always stay the same, right? No matter what. Those arcs, B to C, intercept. Okay, here we go. 10-10. All right. This one's, yes it is, it's colorful. Here's what it says. There's only one color. It says angle C, which is this one I have down here, okay? Angle C is 90 degrees, or a right angle, if and only if, that's what the IFF stands for, if and only if D to B is a diameter. And this makes complete sense because this is just the same thing as the very first theorem, which says that the inscribed angle, which would be 90 degrees, is half the arc. And if the arc is the diameter, then it has to be 180 degrees. So therefore, you know angle C is 90 degrees. It's always going to look like this. That's the whole point. See? The whole point is that no matter where you move, as long as you have the diameter across the circle, then the interior angle has to be 90 degrees. That's the whole point of this whole thing. Yeah. Move it to where B is over where D is. Look, 270. 11. Okay, here's what it says. It's a fill in the blank. I'm going to let you see if you can guess it, okay? It says, so, theorem 10.11, a quadrilateral, so a figure with 4 sides, can be inscribed a circle if and only if its opposite angles are what? Go ahead. Supplementary. You got it. If and only if opposite angles are supplementary. So, no matter what I do to the B, as I move it around, look at this. Oh my gosh. It stays 105 no matter where you go. Holy cow, that is so rad. So amazed by geometry right now. Yeah, rad, like radical. Look at 75 no matter what we do, all the way around. I can move E? Yes. Oh, that moves them, but they still add to what? There you go, boss. See? Very nice, yes. Yeah, here's B. I move B, right? Always going to be the same, right? That circle can get huge. Wow. See, I'm talking about, right? Fun stuff. I'm asking you to do 2 things with your partner. Talk about it right now. I want you to find the measure of the blue arcs. Discuss question A and question B, and also write down the theorem that allows you to say what you think the answer is. Question A and question B. I'll give you 1 minute to think about it. Here we go. Alyssa, you and your partner, what did you come up with for A? Shh. You got 40. How'd you get 40? So you said this had to be 40 by theorem 10.8 because the intercepted arc has to be double the inscribed angle, right? So the angle has to be half of that. So that is the right answer. Nice job. Okay, B. Mandy, what'd you get for B? You did okay. You could go 10.8. Can you do anything else? Can anybody do anything? Another different theorem that goes with that? You could also go 10 point. What is it? 10.10. So that means that KL has to be what? What does KL have to be? The diameter. Yes. Okay. Good. Okay. Take a look at C really quickly. Take a look at C. What does the blue arc in C have to be? Lalo, what do you think, buddy? He says half. The blue arc in C has to be half. What do you think, Brittany? It has to be double this, right? Because this part has to be half of the blue arc. So what does the blue arc have to be? 210. Very good. Okay, good. All right, with your... Oh, okay. Rocio, could you please tell us what you came up with for D? Now, why is this one 115? I don't get it. Why is it? It has to be half of 230. And what did you get for Y over here for part E? 150 because it's what? Has to be twice 75. So what does that make Z? 75 because of theorem 10 point. Which one was it? No, 10.9. Wasn't it 10.9? Okay, last step. Hyro has been working on it. Okay, Hyro. What did you get for Y and how come? Yeah, Y has to be 100. Can you explain why? Yeah, he said the opposite sides, they have to equal 180 degrees. So, Hyro, what does X have to be? 95 degrees. How many have the same thing? Put your hands in the air. Look at all the... Wow, only 5 people got it right?